All right, we're going to jump into these inequalities today, and since we've already worked ourselves into the solving process, we're just going to get right into it at the multi-step level. We treat inequalities the same as we treat equations when we're doing the solving process, but there are a couple of slight differences. We have to pay attention to the sign, greater than or less than, greater than or equal to, less than or equal to. And then we've also got to pay attention when we graph the solutions on a number line. One of the things that's a little bit different is that in an equation, we would have one or two answers, like x equals 4 and x equals 7 or x equals -9. You have that one answer that you know of. Well, when it comes to inequalities, you get something like x is greater than 7. Well, think about the number of numbers that are greater than 7. I mean, that is an infinite number because you're talking about not just the whole numbers 8, 9, 10, 11, 12, 13, 14, keep going. It's all the decimals as well. So 7.0001, 7.0002, and it keeps going from there. So there's an infinite number. So there's no way for you to list every single solution. So we use a graph to help model what all the solutions are because we don't have the ability to write all of them down. So in this lesson, we're not only just going to solve, but we're also going to graph the solution sets, keeping in mind the symbols that I've got highlighted for you. And we're going to be talking about whatever this open circle, closed circle is. It would be a great time for you to go ahead and pause your screen and write down the definitions that I have, as well as some of these symbols here for you. So for instance, an inequality is a mathematical statement using greater than or less than instead of equal to. Again, we talked about it has an infinitely many solutions, not just one solution. We use these symbols greater than or equal to, less than or equal to. And when we graph, we have open circles and closed circles depending on if we're not equal to or we are equal to. One of the things that gets a little bit confusing is trying to remember which symbols go with what. And I always think about it, and this is a little elementary, but I always think about these greater than and less than symbols as alligator mouths, and they always want to bite the larger number. They always want more food. So they bite the large. So the mouth chomps whichever is a larger number. So depending on which way the mouth is chomping, that side is what is larger. So you make sure you're paying attention. Is it the left side that's bigger or the right side that's bigger? And that helps you determine which symbol you're looking at. Okay? So for instance, just to model what we're talking about with graphing the solution set, in this first example, I've got x is already solved. X is already greater than -3. But think about all the numbers that are greater than -3. It's not just -2, -1, 0, 1, 2, and so on. That's just my integers. And then it's all those decimals as well. So it's so many numbers we couldn't possibly write them down. So what we're going to do, and I'll use my red here, this is x is greater than. So it's not greater than or equal to. So it's not equal to. So I'm going to put a circle around -3, which would be right about here. That's where -3 would be. I'll put a circle around that, and it's open, not closed, because -3 is not part of my solution set. But then all the numbers that are bigger than -3 are to the right on this number line. So I'm going to shade all of this, and then I'm going to put an arrow right here at the end indicating that it's going to keep going. And that says every single number in red, all of these are part of my solution set. It doesn't matter how complicated the answer looks. Like 3/2 is the same thing as 1.5. So M is less than or equal to 1.5. So 1.5 is right here. That's 1.5. And it says less than or equal to. So that's why I did a closed circle, because of the or equal to part. And now less than is going to be to the left. So then I'll just shade all of this and then put an arrow on the end, because it's going to keep going, and it's all those numbers. So that's why we have to graph, because we have an infinitely large set of solutions. It's not just one thing. So this is how the graphing is going to work. Now we're going to put this with the solving process and graphing together. All right, so we got us a got us a couple of things just to keep in mind before we jump in. And you might want to pause your screen and just make sure that you have these things written down. When solving multi-step inequalities, your procedure is the same as equations. We already talked about that. We're going to do the reverse order of operations, but if we multiply or divide by a negative number, you have to pay attention and change the greater than or equal to symbol. All right, you say, Mr. Edwards, why? Why would I have to do that? Well, when you multiply or divide by a negative number, you change the sign on a number. So like if you did 5 divided by negative 5, that number 5 divided by negative 5 becomes negative 1. So a positive just became a negative. And when you change the sign, you have to adjust for that on a number line. So when you change the sign, you also have to change the inequality symbol. So when you multiply or divide by a negative, you have to change the inequality symbol, or you flip it over. So if it was greater than, now it's less than. If it was less than, now it's greater than. Again, pause your screen if you'd like to make sure that you got those things written down. Okay, let's do this first example together. Variables on both sides. There's more m's on my left side than my right side, so I'm going to subtract m from both sides. And that's going to give me 3m minus m, or 3m minus 1m is 2m, plus 7 is less than 17. I didn't have to change anything because I didn't affect any other numbers. Now I'm going to subtract 7 from both sides. Now you guys see that negative symbol, and some people might get the urge to try to flip a sign. Remember, we only flip the sign when we divide or multiply by a negative. All right, so my 7's cancel, and I've got 2m is less than 10. Now I'm going to divide both sides by 2, and since that's a positive 2, I don't have to worry about changing the sign. 2 divided by 2 is 1, so those cancel, and m is less than 10 divided by 2, or 5. Okay, now I'm not done. I've got to graph this. This is m is less than 5, so it's all of the numbers, infinitely many, that are smaller than 5. So I'm going to put a 0 as just kind of a landing mark on my number line here. I'm just going to call this 0, and that means 5 is going to be to the right of it. 1, 2, 3, 4, 5 units, and really that's all you need on your number line. I'm going to go open circle because we are talking about less than, not less than or equal to, and then all the numbers that are less than are to the left. So I'm just going to shade all of this and put an arrow right there at the end, and that's how we do it. Okay, let's try another example. All right, a little bit more complicated this time. I'm going to go ahead and distribute so that I don't forget to do it. Remember, that means I got to multiply by negative 3 twice. So negative 6p minus 3 is less than or equal to negative 3p minus 30. Okay, there are actually more p's on the right side. I know it's tempting because 6 is bigger than 3, but negative 6 is a smaller number than negative 3. So I'm actually going to add 6p to both sides. And that's going to give me negative 3 is less than or equal to a positive 3p, and that's why we do that, minus 30. Now I want to add 30 to both sides because I'm trying to isolate the variable. All right, these cancel. And I've got 27. Okay, now I still have 3p, so I've got to get p by itself. That means I'm going to have to divide both sides by 3. Now, 3 is a positive number. I don't have to worry about flipping the sign over, but 27 over 3 is 9, and that's still less than or equal to p. Now, I love this problem because right away you have your variable and your number on opposite sides than they were in the previous example. So if you're looking at this and it feels a little bit weird, you could flip it around, but make sure the mouth is still biting the same number when you flip it around. So when I look at this, the alligator mouth is biting the P. So if I put the P on the left side, the alligator mouth still has to be biting the P. And that's what I've got here. So that is how I could flip it around. If you prefer, look at it like that and to make it graph a little bit easier. So that means P is greater than or equal to 9. So I'm going to put my 0 as a landmark. And then I'm going to count 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9 will be all the way down there. So let's do this. Let's adjust. We'll come back a little bit more. Put my 0 here. And now we'll count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put my 9. This is going to be a closed circle because of the or equal to part. And P is greater than or equal to. The alligator mouth bites the bigger number. So greater than is to the right. Put my arrow to show that it keeps going. Okay. All right, we'll do our final example here with number 3. I love it. It's got fractions in it. A couple of different things that we can do here. You could cross multiply. You can just go ahead and multiply everything by a certain thing. We're going to cross multiply. And in the effort to cross multiply, let me just kind of take some of the confusion out of this problem. Make sure that you agree with what I'm saying. What I've got on the left is going to be the exact same thing as this. Okay, now you're looking at that, you're like, I'm not so sure. Well, think about it. 1/3 times x, you would multiply the top times x. So this is like 1/3 times x over 1. All right? So 1/3 x is the same thing as 1/3 times x over 1. And when you multiply fractions, top times the top, bottom times the bottom, and 1 times x is x, and 3 times 1 is 3. So that's how I got to what I'm talking about here. Now, why would I do that? Well, when you have a fraction on either side, if this was an equation, it would be a fraction is equal to a fraction. That's called a proportion, and that's the perfect setup for cross multiplying. Now, what's cross multiplying? That's a shortcut for us to be able to get rid of fractions on both sides at the same time. So what we're going to end up doing is we're going to multiply the numerator x times the denominator 4, and then the denominator 3 times the numerator 2x minus 14. Cross multiply. So x times 4 is greater than 3 times 2x minus 14. And this gives me the opportunity to get rid of the fractions right away, which makes my life a whole lot easier. Go ahead and do your distribution. X times 4 is 4x is greater than 6x minus, and that's going to be 42. Oh, my goodness. 42. All right, and now we're going to solve. All right, because, typically I would send all the x's to the right because there's more x's over there. But because the 4x is already isolated, I'm going to just subtract 6x from both sides. And this proves that you don't always have to do it the way that I do it. So negative 2x is greater than negative 42. Now is one of those opportunities where you have to be really careful. I've got to get x by itself. The coefficient is negative 2. So to get rid of multiply, I've got to divide. So when I divide by a negative number, I've got to remember to flip the sign. So I'm going to divide both sides, and I'll write this all over again. I've got to divide both sides by a negative 2. Remember, when you divide by a negative, you've got to flip the sign. So x is now less than negative 42 divided by 2, or 21. X is less than 21. Okay, now, big number, which means I don't need to count by ones this time on my number line. Counting maybe by 2s or by 4s or by 5s or by 3s or by 7s, that might be a little bit better. I'm actually going to count by 7s here. So I'm going to make a mark for a 0 just as a reference. And then this will be 3. Sorry, not 3. I'm going to count by 7s. All right. This will be 7, 14, 21, 28, and so on and so forth. So 21 is here. Now we're going to use an open circle. This would be negative 7, negative 14. Open circle because of the less than, not less than or equal to. And remember, I'm going to shade to the left because x is smaller than 21. And all the numbers that are smaller than 21 are out here to the left. Put my arrow because it keeps going. And that's how I do it. So I've given you 3 relatively complicated examples of all the different scenarios. Open circles, closed circles, less than, greater than. And also scenario where we had to flip the sign. Make sure you're paying attention to the details. The solving process is the same, but with a few extra details, flipping signs and graphing. Good luck.